there is 4 different valid equivalent class. Okay, the VEC is actually stand for valid equivalent class. So each of these classes we need to make it unique. So if you recall back the previous slides, you will see there will be unique identifier for each of these classes. So VEC1, VEC2 until VEC4, that is what mean by the unique identifier for each of the valid equivalent classes. How are you? How are you? Yes. Good, huh? Recovered already, huh? Okay. Recovering. And you are already here. Good, huh? Okay. So, as what we have discussed, each of the equivalent classes, we get it from the requirement here, where we get the minimum and the maximum value. So the 4th class, the valid equivalent class for, I'm not going to follow this one. So we will do the correct answer where we have the minimum and the maximum value. And the 3rd column is, as what we have discussed last week, for us to conduct the test. Okay, we just need to choose one representative values from each of these classes. That will be sufficient enough for us to cover the entire range, start from the minimum until the maximum. So only one representative value, as long it is within the given range of the class. Okay, and the expected output, we are going to have another one more column for the expected output, which will come from the scenario straight, where 0%, 5%, 7% and 8.5%. Okay, so I will redesign the table again for you guys. So the next table here is the 2 invalid equivalent classes which we have discussed. Okay, the reason why we need the maximum minimum value is we want to know where will be the invalid data can be. So if you see from this given table, we have the invalid value which is 0. So anything which is less than 0, it is considered as a invalid. But if you see our 4th valid equivalent class, this example did not give us the maximum value. So when there is no maximum value, where we are going to consider the invalid part after the maximum? It's like never ending. Am I right? So that is the reason why every valid equivalent classes we are going to design, we must have the minimum and the maximum. So I think I have mentioned to you, you can put any long numbers, anything more than that, we can assume that this is invalid because it is more than that. Okay? So here normally for the representative value, so the same thing, any example of whatever covering the invalid range, it is acceptable. And for the expected output, we are going to prepare the error message. So when you are going to answer this type of question or for your assignment, you are going to have the output, the expected output for the invalid classes to give us the proper error message. Okay, so now we are going to put into new table where we are going to have another one more column, and I'm going to combine the valid and the invalid together in the same table. Okay, so normally the question will let you know either you need to prepare 2 different tables for valid and for invalid, or if the question said identify all the classes, it means you are going to have one table where you start from the valid equivalent class and then followed by the invalid equivalent class. Okay, so I'm going to show you by combining into one table.
认证。如果等下有第9个人怎样？女生喽。
给他这样就。你可以休息一下，先睡一下。
他突然间11点多没下床，明天有没有打球啊？讲这个车满人。
哪一个？
啊？你们不认识？我给正好有照片了。
哦，我以为是同一个人来的。
啊？你以为他是同个人？
有点像。
像谁？
像那是猜我，是你的猜我。你直接讲是不是？你直接讲是不是？
我给正好照片了，他竟然没有分享。
我想给他们一个惊喜嘛，你就讲出来，那个记住。
我觉得你们很真的很。
永兴也是第一次看到那个送的。这样晚上上的。你还是没有感冒了？
有时上课啊，上到4点。叫他来玩阶段。
Okay, so from the given example here, okay, we have the two tables, okay. How you are going to use the comparison symbol, it's up to you. Either you want to use less than 15,000 or you want to put less than equal to 149999. Okay, as long you are not going to miss out any value. If you see this valid equivalent class, it's end at 14999. So the next class must start from 15,000. So there should be no missing any value happen. Okay, so that one we are going to get confirmation with the second technique if our boundary value has been fulfilled correctly or not. Let's assume if we missed out anything, we can identify it later. Okay, so the comparison symbol, it's up to you how you are going to use it, less than or less than equal to. Okay, as long you are comfortable with what you are going to use. Okay, so if you see our parameter here, based on what the scenario mentioned, it's a sales price. So I'm representing the sales price with X because I'm going to use it into the comparison later. Okay, then this will be the representative value for each of these class. Okay, and this will be the expected output according to the given scenario. And when it comes to invalid equivalent class, we just need 2 here, because when we say that minimum maximum, anything below the minimum, anything more than the maximum, it's sufficient enough to cover the invalid class. So in that situation, you don't need to mention what happened if the sales is using character. What happened if it's using special character? We don't care about it. Okay, because we assume that anything below and anything more than the maximum, it is considered invalid and that is sufficient enough. So let's assume if the question say, give me 4 invalid clauses, 3 or 4, then you can add 2 more extra. But the 2, this is the 2 first. Okay, anything below the minimum, anything more than maximum, it's the first invalid what we must test. Okay, so this will be the representative value and this going to be the error message. So from here, we are going to have how many positive test case? How many negative test case? What is positive test case? What is negative test case? What is positive test case? What is negative test case? I think I have mentioned that last week, right? Yes. So how many positive test case we have?
4.
Sorry? 4. Okay, so we are going to have 4 positive test case and we are going to use that representative value from each of the valid equivalent class. So how about the negative test case? 2. Can we have more? Can we have more negative test case? Actually can. Okay, but the important 2 which we need to cover is the one below the below the minimum, and the one more than the maximum is sufficient. Okay, so this is the first technique, which is the equivalence partitioning. So let's assume for your assignment, the selected module here dealing with something regarding numbers, where you can see the minimum, the maximum. You can see like this is a range, this can be one class, this can be one class. So if your module is dealing with a functionality in this way, then you can actually use this technique for your test design technique under the 1.5 in your test plan. Okay, but the technique is not yet end. We will continue with the second one now. Okay, so the second one is called as boundary value analysis. I don't want to go through a lot of theory things. I will just directly show you what is the meaning of boundary value analysis. So boundary value analysis, where it's a continuous of the equivalent class technique just now, but here we are going to use the borders of the equivalent classes. And when I said boundary value analysis, when we said the borders, it means for the valid equivalent classes only. Because for our invalid equivalent class just now, do we have any border here? Do we have any minimum maximum here? No. So in that situation, the boundary value analysis is only applicable for the valid equivalent class which you identify inside the equivalent partitioning. Okay, so here what we are going to do is we are going to detail out the 4 equivalent classes just now, more specifically to see if we able to cover the border value, because sometimes we missed out this border value where it will be detected wrongly. Suppose when a border value happen in the first partitioning class, okay, in the second partitioning class the same border value must not be there. Okay, whatever valid in the previous class must be invalid for the next class. So this is where we want to make sure if the border value has been identified correctly or not. Okay, so that's why this boundary value analysis can be worked together with the equivalence partitioning. So now from the 4 valid equivalent classes, we want to identify more border value which will be valid and also invalid value, and inside the valid we want to see based on the minimum and the maximum. Okay, so the number of the test case using the boundary value analysis will be more compared to the equivalence partition, because it's going to be more detailed out for each of the class. Okay, so we are going to use this table now. Okay, so if you see boundary value analysis table, we have 3 columns where we have the valid and we have the invalid. So now for each of the valid equivalent class, we identify valid equivalent class 1, 2, 3, 4. We are going to find the boundary values. So for each of the classes under the valid, we are going to identify the minimum, the maximum, and then the minimum plus 1 value and the maximum minus 1 value. This 4 is going to be under the valid. So when it comes to invalid, on the left side we have minimum minus 1 and on the right we have the invalid, which is the maximum plus 1. So in that situation, what will happen? For each of the equivalent classes, we are going to have 4 positive test case and 2 invalid test case. It means 4 positive test case and 2 negative test case for each of the class. So if 4 for each of the, if 6 for each of the class, then for 4 classes just now, we are going to have total of 24 test cases. Just like that. This is just the positive, am I right? From the positive, from the valid equivalent class, not from the valid just now, invalid just now. So that's why the number of test cases we can reach the exhaustive just like that. So it is very important how we are actually to make sure did we cover the range of data correctly or not. That is the important. Okay, so now from the table which we have here, we want to translate this using boundary value analysis. Boundary value analysis, nothing much, just to transfer from here to there. And we only take the valid equivalent classes only. The invalid, we are not going to touch anything. Okay? Okay, is the labeling correct? Is the labeling correct? If the question asks you to prepare the boundary value analysis table, the labeling on the top carry marks. The arrangement for the value, is it correct? Can you check back on the slide? Is it correct? Minimum plus 1, maximum minus 1, and maximum. Correct? Okay, so if this arrangement is not correct, marks will be deducted. Okay, then here will be invalid, which is the minimum minus 1, and here will be invalid, maximum plus 1. So now we are going to identify the border value for each of these equivalent classes. Valid equivalent classes only. You know what that means, right? Only. So you're not going to do anything here. So don't try to do the boundary value analysis for the invalid equivalent classes because you don't have the minimum value, you don't have the maximum value. So I don't want to see any funny answers in your midterm or in your final exam later. Got it? Okay. So let's start to put the values. Okay. So let's start with the valid values. So for the first class, what is the 4 valid values? Sorry, start from 0, 1, sorry, Anyone wondering how that happened? Okay. Invalid? Negative 1. Invalid? Sorry, what happened? ？Okay, invalid. Okay. Second valid equivalent class minimum. Sorry. Correct. Okay, invalid. Invalid. Okay. The third class minimum. Invalid. Okay, the last one minimum. This is the maximum. So how many nines I'm going to have? Thank you. Okay, here. Yes, that's what I did. Okay, so if you see in the table which is given in the slide, okay, for the last class what happened, they didn't give us the maximum value, correct, in your slide. It's just that more than 25 onwards, correct. So if you don't have the maximum value, what will happen is you are not going to have this maximum, you are not going to have this maximum minus 1, and you are not going to have this invalid. So this is the reason why I said when the question give you the maximum, okay, you can put the value. When the question didn't put the maximum value, you create 1. Because for the boundary value analysis, you cannot just leave it as infinite. We still need the value. Okay, so from the boundary value analysis, what we are trying to see here is the valid value of one equivalent class cannot be repeated in the following class. If you do, you have repeated value, it means you didn't cover the boundary correctly. So it means the mistake might be using the symbol here. You get? That's why I said less than, equal to, be careful how you are using it. Okay? So if you see from the 4 valid equivalent class just now, where we have the 4 test case just now, now each of the valid equivalent class, excuse me? Are you in my class?
No.
Then why you came inside?
Just for the aircon.
For the aircon.
Sorry.
Are you sure? Because I see you last week also.
Yeah.
Are you taking attendance for someone else?
No.
Are you sure?
Yeah.
Can I check your phone?
Sure.
Can I know which program are you?
RIS.
RIS.
Yeah.
And where your class supposed should be?
I'm actually waiting for someone.
Waiting for someone.
Yeah.
and you can just come into my class just like that.
Sorry.
I'm not going to see your face again now. Okay, so from each of the valid equivalent classes, what will happen now is we are going to have more accurate test cases where we will cover each of the border value, because sometimes this border value can cause defect. So that's why we have to know the border will be covered in which range of the class. Got it? So for each of the test case here, for each of the valid equivalent class, we are going to have 4 valid values and 2 invalid values. So it means for each of the class, we will have total of 6 test cases. Got it? So that's why I said we are going to have total of 24 test cases just for this scenario. Got it? So normally if we stop at equivalent class, okay, we are just going to have 4 valid and 2 invalid. But we might not able to cover the correct borders. To check the borders, the valid and invalid for each of the borders. So that's why the the equivalence partitioning will be moved to the boundary value analysis, so that we can see much more accurate numbers for us to conduct the testing. So these 2 pair, they come together. So if your modules dealing with numbers, dealing with range of numbers, dealing with minimum, maximum values, valid, invalid, then this is the suitable technique for you to use. Clear? Clear? Okay, so I'm done with the first 2 techniques. Any question? All this is actually just examples, taking like so many slides. Okay, so I have just simplified based on what you need to understand. Okay, so let's assume there is question asking you to prepare this and it can carry 15 marks. So make sure the labeling. Yeah, these 2 tables. Okay, so normally 10 marks for the equivalent side and then 5 marks. And what you do in the equivalence, that is what you need to transfer into a boundary value analysis. So is it consistent? That carry marks. Okay? Okay, so any question before I move to the second pair of the technique? Clear? Okay. So the second pair of the technique, this one I'm not going to cover it. This is not part of your assignment use. Okay, it is not part of your examination or midterm use, but it's just for lecture, because that is more to UI things. Okay, so I will just go through in the lecture, but this is what we are going to use more, which is the cause effect graph and the decision table. Okay, so compared to equivalence partitioning and the boundary value analysis just now, when we said cause effect decision table, this is more to the modules or more to the functionality, which is having a cause and what will be the effect due to that cause. So for example, when we have login function, okay, so when I give valid username, valid password, what will be the effect? It should be successful login, am I right? So if I give invalid username, what will be the effect? If I give invalid password, what will be the effect? So it means when there is different causes happen, different effects need to be tested, if this effects is working or not. Okay, so let's assume that if your modules, the functionality of your modules is more to this kind of modules. It means like more to action based, more to where you can clearly see that, okay, this is causes, this is effect, then this will be the suitable technique to use. Okay, so for the cause effect graphing, okay, where this is more to the logical relationship. You have discussed logical before, am I right? The one using the AND logic, using OR logic, not logic, not logic, you know, the not on the opposite. Okay, not the not logic. Okay, so we are going to use that back here. So it means when more than one causes is being combined as AND logic, what happened? If it's combined with OR logic, what happened? If it's a not logic, what happened? So that is what we are going to use here. So we call it as a cause effect graph, where we are going to have a list of causes, we are going to have list of effect, and we are going to show how is the logical relationship between the causes and the effect. So from there, we are going to prepare our graph and our decision table, where our decision table will give us the number of test cases, minimum number of test cases which we can test. Okay, all these 4 test design technique actually guiding us to get the minimum number of test cases. Actually, we can go more. Okay, so we get the minimum number. Okay, so every causes is going to be described as a conditions, and then the combination of this condition will be connected using the logical operator. So like what I said, and, or not, and then what will be the effect? Is it going to be true or is it going to be false? So that's what we are going to see. Okay, so this is an example how we are going to use the symbols. Okay, so this this symbol is representing the AND logic. Okay, where before that, the one in a green, the C1, C2, that is presenting the cause. Okay, I will show you how we get that. And then the one in E, the blue one, is actually the effect. Okay, so each of these causes, each of these effects, we will be having the numbering to differentiate them. Okay, and we are going to have the symbol to indicate what logic we are using. So here, AND logic, when the C1 and C2 are connected with the AND logic, this is how we will draw it. This one is the OR logic. Okay, C1 and C2 is combined with OR logic, and this one is the NOT. Okay, how we normally do the NOT in programming, not equal or not. Am I right? Okay, so here this is the symbol to indicate that it's going to be on the opposite. If it's true, it's going to be false. If it's false, then it will be true. And we have another one more, which is called mutually exclusive. And this drawing of the line is actually happen outside of the cause. Okay, later we will see. So this mutual exclusive is when these two given condition cannot happen together. It means only one can be true at a time. It means you want to clearly show that these two cannot be combined with AND or with OR, because only one will happen at a time. Okay. Okay, so let's see a situation here. So later from the situation, we will see the cause effect graph. Okay, so the given situation here is the print message is software that read 2 characters. Okay, and depending on their values, what message will be printed out. So it means the cause here will be the values, and then the effect here will be the message will be printed according to that. Okay, so the first character must be an A or B. Okay, must be A or B. First character. Is everything okay? Okay, so the first character must be A or B? Can A and B happen together? Because it's only one character and the character can be A or B. So these two cannot happen together. It will be A or B. So this is what we said as a mutually exclusive. It cannot happen together because we have only one space there. We have only one character and the character must be A or B. So A and B cannot work together here. Okay. Then the second character must be a digit. Okay. So this is more to the cause. Okay. The first character should be A or B. Then the second character must be a digit. So now let's check what are the condition and what will happen due to that condition. Okay, so if the first character is an A or B and the second character is a digit, file must be updated. So it's going to print a message, file must be updated. So it means our causes will be combined with AND logic. Can you see if the first character is A or B and the second character is a digit, then the message file must be updated will be printed. So our effect here is file must be updated. Okay. Then if the first character is incorrect, it means it is not A, it is not B. Okay. And the message X must be printed. So the effect here is message X must be printed. So what happened to the second character? What happened to the second character? Are we checking anything on the second character? Actually, we are not checking that. So we assume that there is no issue on the second character. It means it is a digit. Okay. Then if the second character is incorrect, it means it is not a digit. So what happened to the first character now? It is remain A or B. Okay. Then the message Y must be printed. So if you see, we have three effects happening here. One is file must be updated. One is message X must be printed. And then the third one is message Y must be printed. And these effects happen due to different conditions. Okay. So this is the list of the causes and the list of the effects. Okay, if you see, first character is A. We present this cause by using C1. Remember just now in the picture we have the number. So this is how we will get the number. Okay, and then the first character is B. This is presented by cause 2. Okay, and then the second character is a digit. This is cause 3. So I have a question here. Can I combine C1 and C2 as one cause? Cannot. Because we are checking them individually. So cannot be combined. Okay. Then we have total of 3 effects, which is update the file, print message X, and print message Y. And we are going to use the E to represent the effect. So we have effect 1, effect 2, effect 3. So now when we draw the cause effect graph, we are going to use the short form. We are not going to use the statement. So before you will draw the cause effect graph, you need to list this down correctly. What you write here, this is what you are transferring into a graph. So if you write here wrong, then cannot be understandable anymore. Okay, your graph will not be understood. Okay, so this is how we are transferring them. So all the causes will be on the left, all the effect will be on the right. Okay, cause 1, cause 2, cause 3, effect 1, effect 2, effect 3. Please correct it. The last one, please put E3, not E1, E3. Okay, the arrangement doesn't matter. The arrangement of the causes, the arrangement of the effect doesn't matter. Whichever way, as long it's not look messy. Because if it's look messy, then it will not be clearly able to see the line. So you want to bring however you want, it's okay. As long all the causes on the left, all the effects on the right. That's the important thing. Okay, so now we are going to do the drawing for each of the effect. Okay, so effect 1 is to update the file. Am I right? So we are going to draw for each of the effect. So let's start with the effect 1. Effect 1 or E1 is to update the file. So the file is updated. When the file suppose should be updated? When the first character is A and the second character is digit, or when the first character is B and the second character is a digit. Okay, so if you see here, A or B cannot happen together. Okay, so now what we are going to put here is C1. If you confuse, refer back to the previous. What is the mean of C1, C2, C3? Okay, so C1 and C3 should be true. It means A digit. C2 and C3 should be true. So it means B digit. C1 and C2 cannot happen together. So we are going to put the mutually exclusive line there. Okay. So we are going to have something like this. Okay. If you see C1, C2, okay, these two cannot happen together. Am I right? So we have this line. C1, C2 need to be checked, correct? And we are going to use the OR logic to check either it's A or B. And this output, okay, if you see this circle is actually to combine this together and bring another line from there. If you don't want to draw the circle, can also, no problem. As long we can clearly see these two is combined as OR. Because only A or B can happen. So we need to also put the OR here to show that only one can come out from here. And whatever coming out from here will be combined with the C3 using the AND logic. Because the second character must be digit. And the second character must be combined with A or B. So it must be used the AND logic. And we are going to get effect 1. Where is the question? Where is the question? Clear? Clear? Okay? Okay. So this is for effect 1. It means when the first character is A or B and combined with the second character is a digit. So this will be happen. Clear? Effect 1? Okay, now? Okay. So let's move to effect 2. So effect 2 is it's going to print message X. And when it's going to happen? When the first character is not A or not B. So it means neither A nor B. It means none of it. Okay. And what happened to our C3? Suppose should be no issue. Because we are not checking on the C3. We are checking only the C1 and C2. Okay. So what will happen here is, since we already have the C1, C2 connected with the OR logic, we are already able to get the output from there. So what we need to do for effect 2 is, we just need to put the NOT symbol to indicate that whatever coming out from this OR logic will be NOT. It means not A, not B. Then our effect 2 can be tested. So this, sorry for the ugly line. So this should be the NOT logic. Got it? Clear? So let's assume if you still want to draw one line from C3. So it means, is there any issue on the C3 here? Is it any issue with the C3 here? No issue on the C3. It's remain digit because we are only checking the first character. So when you want to combine this output with C3, C3 will be still remain no issue. Got it? And if we are not testing that, if you don't want to include also, doesn't matter. So it's depend on the requirement. Okay? So let's move to the E3. Okay? So E3, it's going to print message Y. When it's going to print the message Y? When the second character is not digit. So what happened to C1, C2? Any issue? No. So it's going to remain A or B, but the combined part with the C3. C3 is the issue here where when it's not a digit. So it means you just put the not logic here to indicate this is not digit. So the message Y will be printed. Got it? Clear? So we are having the list of causes, we are having the list of effects, and the logical relationship, how this effect will be connected or how this effect will happen or when it will happen. Got it? Clear? Okay, so now from here, not this one, from here we are going to move it to the second technique, which is the decision table technique. So decision table, it's not a stand-alone technique. Decision table cannot happen by itself. What you draw on the cause effect graph, that is what you are transferring into the decision table. So if you are answering this question, what you draw there, that is what you need to transfer here. At least if it's wrong, you still need to transfer it. At least I can give you the transferring mark. Got it? It means you understand that, okay, what you do there, that's what you are transferring here. So it's a right or wrong, later story. So these two sides must be consistent. Like how from equivalent partitioning, we move to the boundary value analysis. The same thing happened here. From the cause effect graph, you need to transfer to the decision table. Clear? Okay. So the list of the causes, the list of the effect, nothing will change. Nothing, no more extra, no less causes, less effects, nothing change. Everything will be transferred exactly. Okay? So this is how we are going to have it. So we have back all the list of causes, C1, C2, C3, and then we have the below part, we will have the effect. Effect 1, effect 2, effect 3. So now when we are drawing the decision table, it means when we are filling up the decision table, we use this binary. Okay, either you want to use 1, 0, you want to use true, false, you want to use yes, no. Okay, so T, F, true, false. Okay, or if you don't want to use that, you want to use yes, no, then you use Y, N. And if you want to use 1, 0. 1 is presenting the true part, 0 is presenting the false part. Okay. Try not to use YN, yes, no. I don't really go with it. Either true, false or 1, 0. Okay. So now for us to fill up the decision table, we fill up from the effect. So when we are preparing this decision table, okay, when we want to prepare our test case, what is the aim of the test case? What is the aim of test case? You want to see the effect happen, correct? So it means just now we have effect 1, effect 2, effect 3, right? We want to see if each of these effect happen correctly or not. So when we are filling up the E part, we only fill up true or 1. There is no possibility to test the false part to happen. False part happened due to the defect. But that is not what we are testing. We want to make sure the effect is happened. So when we fill up the table, we must fill up as true. So it means effect 1 to happen, effect 2 to happen. So you are not going to put 0 there. You are not going to put F there. But you are going to put true or you are going to put 1. So now we will start from effect 1. Still remember what was the effect 1 just now? Already forgot. What is the effect 1? File to be updated. And what was the conditions? What was the causes just now? Okay, it's C1 or C2 and combined with C3 with AND logic. Okay, so now when we are filling up, okay, since we have this or, A or B, is this happen together? Can we test them together if A or B working together? It cannot be happen in one test case, correct? It cannot happen in one test case, correct? Okay, so whenever there is OR logic, whenever there is OR logic, it means either this one or this one. It means we are going to separate into 2 test cases. Okay, normally the minimum number of test cases here or the minimum number of column here based on how many courses we are having. So here we have C1 or C2. So it means we just need 2 columns or 2 test cases to test them. Okay, so 1 to test the A, 1 to test the B. So if you see, 1 column is for the A, 1 column is for the B. Got it? So the one we are not testing, we leave them empty. Can you see here the C2 is empty, the second column C1 is empty. Okay, clear? But any issue on the C3? We need to test them every time we are testing A or B, am I right? So the C3 will be combined together. So A and the digit, B and the digit. So we want to test the effect 1 where the file must be updated when A and a digit being combined or B and the digit being combined. So we have 2 test cases here already. These 2 test cases to test effect 1. Okay, so just to make you understand, when you use OR logic, you need to separate them. When you use AND logic, you combine them together. Clear? Can? Okay, so now from the effect 1, we move to effect 2. What is the effect 2 just now? What is the effect 2 just now? To print X message. When this message will be printed? Not A or B. Anything happen to the C3 here? Nothing happened. So what we will do is, since it's a OR, we will have another 2 more test case or another 2 more columns here where the first one, when the C1 is 0 and the C3 remain 1. It means no issue on the C3. Okay, and the 4th column here is when the C2 is not B and the C3 remain digit, no issue. So we will test the effect 2. So we have 2 test case to test effect 1, 2 test case to test the effect 2 because of the OR logic there. Clear? So whatever we are not using it, leave them empty. Okay, leave them empty. Okay, got it? Any questions so far? Okay. Let's move to the E3. So E3, when it will have, what is the effect first? E3, what is the effect? What is the effect E3 just now?
Y and
Huh?
Y.
What is the effect?
What's the effect? Y must be 3.
Okay, Y must be printed. And when the Y will be printed?
Not C.
When the C3 is not a digit. Am I right?
Yes.
So, what will happen here? The 1 will change into 0 now. So, it means when the C3 is 0. Got it? When the C3 is 0. So, what happened to C1 and C2? Any issue? Because we have all combination there, am I right? So we need to make sure that when the not digit happen with the C1, we need to test it. And when the not digit happen with the C2, also we need to test it, minimum. So we will have 2 test cases to confirm that when these 2 situations happen, effect 3 will happen. Got it? Okay, just ignore the last table because normally the empty one, right? They will just fill up with the 0, but I will not recommend you to do that. So anything false, use the 0. Anything we are not using them for the test case testing, leave them empty or just put dash. Because if no means it will confuse you. Okay, so the same thing goes for the effect, right? For the effect here, we only use 1 or true to test the effect. So whatever we don't test, just put the dash. So if you see 1 column testing 1 effect at a time. Okay, so here each of this column you will put the test case number on the top. Test case 1, 2, 3, 4, 5 and 6. So that's what I was saying, test case just now. So effect 1, there is 2 test case. Test case 1, test case 2. Effect 2, there is 2 test case, which is test case 3, test case 4. And then effect 3, there is 2 test case, which is test case 5 and 6. Got it? Clear? Can transfer from the cause effect graph to the decision table. This is the simplest example I can give. Okay, so what you draw there, that's what you are translating into the decision table. Okay, let's see this example. What you understand? Okay, if you see some example, the circle itself, they put the statement inside, which I don't want you to do. You know what will happen later on your midterm or final exam with your handwriting? It's going to take like the entire page with a big one. So don't do that. So list down the causes and the effect like this. And then use the C1, C2, E1, E2 nicely inside the circle. So don't try this at home. Okay? This is just an example. So you list down all the causes, list down all the effect, then use the short form for you to draw the circle. Okay, so let's see this example of, what system is this? There is no scenario given, so we try to understand from the graph itself. It is the ATM card, okay, where there is 5 different effects here. Let's try to understand the effect, then we move to the causes. So the first effect is reject card. When the ATM card can be rejected. Okay, then ask new PIN. When the ATM machine can ask for new PIN. Okay, and then eat card. Okay, you know, right? ATM machine can eat card, right? Because if you do something against what the machine want, then it can eat your card. Okay, then ask new amount, and the last one is going to pay you money. This is 5 effect. On the right is effect. Okay, now we see the causes. So the first one is bank card is valid. Then the second one is PIN is correct. Then third, PIN input. So it means we have tried for 3 times. Okay, and then money available. Okay, one important thing. If you see here, since we have the not symbol, not, it means when it's true, it becomes false. When it's false, it becomes true. So for example, bank card is valid. If I put the symbol of not, it means bank card is not valid. That is the meaning. Money available. If I put the not logic, it means money is not available. So, since we have this not logic, I'm not going to accept any repetition of the causes in the positive sound and the negative sound. Because I'm going to ask you what happened to the not logic. I will write on the midterm, on the final exam. Do you get what I'm saying? So you must use the not logic. If we have these 4, I don't want to see 8 causes. Because you will put bank card is valid. Then the second cause, bank card is not valid. Then PIN is correct. The following PIN is incorrect. And what is the purpose of the not logic here if you're not using it? Do you get? So, when you put something like that, I will deduct mark and I will ask the question then. What happened to the not logic? Clear? Clear? Okay. So, let's see what happened here. So, when the effect reject card can happen? When the effect reject card can happen? When reject card happen? When the card is not valid. Okay, it can be due to any reason, but when the card is not valid, so we use the not logic then. When the card is not valid, can we test other things? No, so that's why only one cause going here. Got it? Okay, let's see the second one. Ask new PIN. When this effect will happen? For this effect to happen, first bank card must be valid. Correct? Then we are going to put correct PIN or incorrect PIN? Incorrect PIN. So we have the not logic here. And then, is it already entered 3 times? When already 3 times, is it still asking for new PIN? No. So that's why third PIN input also is not. So all these must happen together. That's why we combine with the AND logic. Got it? Because we need to check the bank card must be valid. And the PIN entered is incorrect. But at the same time, it's not happened for 3 times. If it's already happened for the 3 times, it will not do that effect. Because it's going to eat the card. So that's why we need to check them together. When it's together means we used AND logic. Got it? Clear? Any question? The third effect, eat card. When it will happen? When the bank card is valid, when the PIN is incorrect, and what happened? When it's already third PIN input. It means you already exit the third time. So it's going to eat the card. Because you are not the owner of the card. How can you forget the PIN number for 3 times? So it's going to eat the card. Got it? So we are combining the same 3 but the first one is the valid, the second one is incorrect, and the third one also happened for 3 times. So this also we combine with the AND logic. It means only if all this happen, then this effect will happen. Okay. Then the next one is ask new amount. When the bank card is valid, when the PIN is correct, and is the money available? No. When the money is not available, then it's asking for enter new amount. Is the ATM really do that? It will just give message, right? You have insufficient amount. Okay. So this must happen. Okay. Then it's going to show, or it's going to ask for the new amount. So the last effect here, pay money. So this will be when the bank card is valid, when the PIN is correct, and when the money is available. So all these 3 must be combined with the AND logic, then only the last one will happen. Okay. So this is something to show that there are some precondition must be happening. If you see, if the bank card is not valid, the other effects will not happen. So for other effects to happen, can you see, we always test the bank card must be valid. The PIN must be correct. Then only some things can happen. So the same thing goes for your assignment. Let's assume you are using this technique, and if the function required login, so it means you must log in, then only you can proceed with this function. It means you need to check the login to that. You need to include the success of the login also. It means the username, the password must be valid, then only it can proceed with other functions or other effects. Got it? So later we will discuss about that. Okay, so now to transfer this into the decision table. Okay, so these are the condition just now and also the action. So we have the 4 condition or 4 causes and then the 5 effects. Okay, so if you see, since we are using AND logic, is there any OR logic just now? No OR logic, only AND logic. So AND logic, we will combine them in one test case. It means all must happen at the same time. So it will be in one test case. Okay, so if you see here this example using AND why? No, yes, because the way the decision table is prepared as a question. So that's why it is suitable to use the yes or no. So bank card valid? Yes, what happened? No, what happened? Okay, so they fill up the table. If you see the test case 1 to test the reject card effect, test case 2 to test the ask for new PIN, then eat card, ask for new amount and pay cash. Okay, so for reject card to happen, bank card valid? Yes or no? Reject card, bank card valid or no? No. So it means it is not valid. So can you see the others? We are not testing them. Once the bank card is not valid, the others is not going to be tested. Okay. Then the second one, ask for new PIN. When it's happened? When the bank card is valid. When the bank card is valid, but when the PIN is incorrect and the third PIN is not being attempted. Okay. Then the third test case is for eat card. When it's happened? When the bank card is valid, when the PIN is correct. PIN is not correct and the third PIN has been attempted. Okay. Then the fourth one is ask for new amount. When the bank card is valid, when the PIN is correct. When the PIN is correct, do we need to test the third PIN attempt? No need. So that's why it's dash here. And then is the money available? No. So that's why it's asking for the new amount. Then the last test case here, pay cash. So this when it happened, when the bank card is valid, when the PIN is correct, and when the money is available, then the last effect can be tested. So since we use AND logic, we test them all together in each of the test case. Done. So only if we use OR logic, then we can have more than one situation to happen. So we need to separate into different test cases. So the number of test cases will be more if we are using OR logic. Okay? Got it? Okay. So as what I have said yesterday, I have finished the 4 techniques. So these 2 pairs, the equivalence partitioning, boundary value analysis, 1 pair, and the cause effect graph and the decision table, 1 pair. Okay, so for each of your individual module which you have selected as your test item, before you will prepare the test case, you need to use the test design technique to identify the minimum number of test cases and how we are going to test them. Okay, so if your module can be using the first technique, it means we have like a range of data dealing with the numbers, dealing with the minimum, maximum values, then you will use the first pair technique. Okay, if your module and the selected functionalities is more to causes and the effect or conditions based or action based, then you can use the cause effect graph and decision table. Okay, so this is individual work, individual marks. So each of you, your own module, you need to choose which pair of technique is suitable to use. Okay, so as an entire team, you might end up using the same technique or you might not. So sometimes one module you might even need both of the pair. Okay, so it's up to you how you understand the functionalities. Okay, got it? Clear? So my tutorial group, the one I'm going to see you next week, group 2, group 1. So this is what I was explaining. So next week when we are meeting for your practical session, make sure you already know what technique you want to use. So this is the hands-on things which I said, to prepare the table, to prepare the graph, all this is what I said. So each of you, you need to come up with this. Okay, so any question before I go to the last part of the chapter? Any question about the technique? Oh, you don't even get it, what I was talking alone just now. Okay, our tutorial question and also some practical questions included about the technique. So during the lecture, during the tutorial time, during the practical time, we will see more questions. Okay? Okay, so the last part of the chapter here, okay, is the pairwise testing. So pairwise testing here, I'm not going to assess it in the assignment or in the midterm or final exam, but this is just to show that there is another one more technique, okay, where it is using the combining method. So it is actually more to user interface elements. So when we have a testing to be done, based on the user interface element, for example, like text field, we have list, we have a menu, we have radio button, you know, those kind of user interface element. So how we can combine to test them? Because when a text field is valid, what happened to other object? When the text field is invalid, what happened to the other object? Because we need to combine them and to do the testing. So this is actually more to UI, okay, UI equivalence based on the UI element. So in here also we can identify the valid and also the invalid values which we must test them. Okay, so let's see example. So this is the given situation. So an application with a simple list box. All of you know what is list box, right? Forgot. When was the last time you do web designing? Okay, you have the list box. So inside the list box we have 10 elements. Okay, so let's say the 10 elements come from 0 to 9. Okay, along with a checkbox. You know what is checkbox? Okay, then we have radio button, okay, text box and OK button. Okay, so these are the user interface objects. Okay, so the constraint for the text box is it can accept values only between 1 to 100. This is just a text box. Okay, so below are the values that each one of the graphical user interface object can take. So for the list box just now, we have 0 to 9. Okay, we have 10 elements. And then for the checkbox, we have 2. Either it's going to be check or uncheck. Okay, then we have radio button, which is the on, off. Okay, then for the text box, what happened? How many values we have? 1000. Okay, 100. Okay, we have any value between 100, 1 to 100. So, we have 10, we have 2, we have 2, and we have 100 of inputs to test. Correct? So, what will happen? So, the total number of test cases using the Cartesian method. So, we just times everything and we are going to have total of 4,000 test cases. 4,000 test cases just to test these values. When you are going to finish the testing?
Walk out.
Equal to 4,000 here means only the valid one. Only the positive one. How about the invalid one? We didn't include the invalid, correct? We said 1 to 100 is valid. What happened below 1? What happened more than 1? What happened if the list box is having other than the 10? Do you get? So the possibilities here will be more than 4,000, which I don't know what's number. Okay. So now this is considered as exhaustive testing. Correct? Because you're not going to able to finish it. Okay. So now the idea here is we want to bring down the test case number. First, we want to use the conventional software testing technique. So conventional software testing technique where we are trying to limit the values. So what we can do is for the list box, which we have 10 elements, we can group them into 2, which is 0, which is not positive, not negative, 0, and we have another one more choice, any values 1 to 9. So we group them into 2 groups only, because anything which we test 1 to 9 suppose should give us the same result. So we don't need to test 9 times. We can use any one. So we group them into 2 here. One is 0, one is to others, which is 1 to 9. Okay. The second one, radio button checkbox. Any possibilities to reduce it? That is the only one. Either it's a on, off, check or uncheck. It's a must. Okay. Text box. From the any values 1 to 100, what we can do? We can group them into 3 different input where we can check valid integer. It means any value presenting the valid integer. Then anything which is less than the minimum, more than the minimum can be counted as an invalid integer, and other than that, anything other than integer also can be invalid. if it's needed. So we can have 3 groups here. So what happened? The list box we have reduced from 10 to 2. The radio button remain 2. The text box remain 2. And the text box just now from the, I don't know, because it's 100 for the valid, more than 100, we make it 3. So now with the same technique, what we get? We get total of 24 test cases. And these test cases include the negative test cases. Correct? Because we already include the negative values there. Okay, this is using the conventional software testing technique. Okay, so now from there we want to reduce more by using the pairwise testing. Okay, where we are going to make sure that we can reduce them at the same time we can combine them correctly, because combining the object, the right valid and invalid is very important, because that can actually bring the test case number up. Okay, so what we can do is, can you see the table here? We have 4 columns, which is the text box, list box, check box and the radio button. So for the radio button checkbox, we have the same option, either check, uncheck, on, off. Okay, but to combine them with the others, let's see what happened here. When the text box is valid, it means any values from 1 to 100 valid. Okay, we can test them in 2 different scenarios, where when the text box is valid, list box is 0 and the check box is check and the radio button is on. So this is one pair. They have been combined and this become one pair. It means combined together and this will be one test case. Then the same valid text box, okay, the list box will be taking any other value from 1 to 9. Okay, then the check box is unchecked and the radio button will be off. This is another situation. But is it sufficient actually? Actually, it's not sufficient, am I right? Because there is possibilities to happen when the check box is on the opposite, when the radio button will be on the opposite too. Okay, then, but this is the minimum we can have. Okay, then the second situation is when the text box is using the invalid. So invalid here means 1 can be less than 0, or sorry, less than 1. 1 can be more than 100. That is what it means by invalid here. So for each of them, the same situation, list box will be 0 or the other value. And then the check box will be check, uncheck. And the radio button will be on, off. Then the last situation is when the text box is receiving other than digit. So any special characters or anything else, okay, or characters, okay. So this will be tested with the same combination of the list box 0 or the others, and then the check, uncheck, and the radio button on, off. So if you see from this pair, we can bring the more than 4,000 test cases to 24 test cases using the conventional software testing technique, and from there, using the pairwise, we can make it to 6 test cases, 6 minimum test cases. Because if we want to test the the checkbox and the radio button, we can actually have another additional 2 in each of them. But the minimum we can have is the 6. Okay, so this technique actually is not really suitable for your assignment, because yours is more to functionality, because your assignment scope is covering the functionality side. So that's why we don't want to be bothered about the UI objects. So our test case numbers are not going to be based on the UI element, but our assignment is going to cover based on the functionalities. Okay, so that's why it's not suitable to use this for your assignment technique. So we use the first four which I have discussed, the two pairs. Okay, so equivalent partitioning and boundary value analysis, or using the cause effect graph and the decision table. Okay, so this one is nothing to do about the technique. So as part of the black box testing, okay, sometimes experience-based testing happen, especially when the testing is being performed by experienced tester, okay, experienced test analyst or technical test analyst or quality assurance people. So when they have too much numbers of experience, knowledge, testing similar systems, so they don't really bother to implement the technique sometimes. Okay, so when we are learning, of course we need to know, we need to learn about the technique. But let's assume after 10-20 years you are in experience under the testing area, then you can actually use experience-based testing. Okay, so this experience-based will be 100% based on the tester's experience. Okay, on the software testing and also on the development. Okay, so there are some example of experience-based testing where the first one is error guessing, second one is checklist-based testing, exploratory testing, and then attack testing. Okay, so error guessing means based on your experience. Okay, like by seeing your face, I can say, you know, that is based on the experience. So something like that, when you are working on a new system or similar domain system, you can already have the guessing where the error can happen, where the possibilities of the error can happen, what type of error can happen, which functionality has the high possibilities for the error to happen. You can guess, especially when you have been working on the similar domain for long, you can actually do that. So this is more on the error guessing based on the experience before we can move that into a formal way. Okay, then checklist based testing based on the experience of the testers. They might have a checklist. So before we can conduct the documented way of testing, they actually use the checklist to check some things. So they will do the testing based on the checklist what they have prepared. So this checklist is coming based on the experience. Then remember, one of the black box testing I have discussed about exploratory testing, where the testers, experienced testers, they will explore the system by themselves according to their availability, according to their time, their experience. So they will explore the system by themselves, and then they will come up with something. Okay, then the last one is the attack testing. So based on the tester's experience, they don't need to follow certain document. They don't need to follow certain step action. They can simply attack any functionality. Attack means not like fight attack, but it's just like they can simply give any input to see what happened. You know, like later for your final exam, right? Like you are doing the testing with your supervisor, with your moderator. The moderator might not even remember what your system about. They don't remember the requirement and so on. So what will happen? They will simply ask you to do something to see if you have worked on it or not, especially when it comes to the error handling part. Give this input, put this number. Did you check? Did you do the validation or not? So those is attack testing. Okay, so this is the experience-based testing where the test cases will be derived from the tester's experience, tester's knowledge, tester's skill. So based on their past experience working on the similar application or technology, or they have been in a testing field for long, so they actually have able to do that. Okay, so this technique will be helpful in looking out the test cases which is not easily identified by structured one. Okay, so sometimes we might not look into something. We might not miss. We might miss out something which is we thought that it is not important, but based on the experience, they find out something. Okay, so when should use experience-based technique? When the requirement document or when the specification are not available. It means when we don't know what is the SRS say, we don't know what is the requirement is actually about. So that is when the experience base is needed. Okay, when the requirements are inadequate, sometimes there is missing requirement, we don't really clear with the whatever document they give us, then that can be a situation. And limited knowledge of the software product, when we don't have enough time to study the product. Okay, then the last one is the time constraint. It means we cannot really follow day by day according to the documentation one by one. So when time constraint, then it is preferable to use the experienced tester because they can move things fast. Okay, so that is our chapter 4. So, any question? Any question? Okay, just to recall. Okay, so now this is where we are going to use the test design technique. Okay, doesn't matter you are with Miss Yasuta or Miss Marina. Okay, so 1.5.1 is where you are going to prepare the test design technique. Okay, later you have to make sure that the test design technique, your test data and your test cases must be tallied. This is very important. That's why I say that don't do the test case first, because you need to do the test design technique according to your test case, according to the valid, invalid or true, false. You need to prepare the test data which you will need for your testing, and then you will prepare the test cases. So don't go and jump start to do the test case first. Okay? Clear? Got it? Okay, any question? Okay, so if there's no question, then we can end the session here. Yeah, one more thing. Our midterm suppose should be on week 8. Am I right? And normally I will do midterm during the lecture hours. So since our week 8 is going to be public holiday, and I'm going to move the midterm to week 9. Okay, so I'm actually expecting reply because I'm not going to do the midterm here because it's a very compact venue, you know. So I might do the midterm on week 9 Tuesday during our replacement on week 9. Okay, actually they say that week 10 the venue is available. Week 10 Tuesday. But I'm asking week 9 Tuesday. So whatever I get from the office, I will update it on the Google Classroom. Okay, so our midterm is moved to from week 8 to week 9 or week 10. I will confirm that. But it's going to be on the Tuesday replacement hours. Okay. Your midterm will be covering chapter 1 until chapter 7.
What the fuck？
Chapter 1 to 7.
Okay? So, make sure that we're able to finish it by then. So, we will see how our lecture is moving.